All right, everyone. We're going to pick back up with the operant conditioning presentation, working on shaping behavior and intermittent reinforcement stuff. So we had talked previously in the last lecture about continuous reinforcement. And remember, if we're talking about a continuous reinforcement schedule, we're talking about a situation where whatever organism we're trying to train or acquire learning is every time we see evidence or an occurrence of the target behavior, we're going to reinforce on each occurrence. Okay, and we talked about how continuous reinforcement is good in terms of shaping a behavior. Continuous reinforcement is very good at communicating to an organism what it's supposed to do, right? What it's going to get rewarded for. And the higher the reward or the more desirable the reward, the greater the magnitude of response is going to be, right? So continuous reinforcement being very good for acquiring behavior, but the drawback is if we stop reinforcing, if we no longer reinforce that behavior and and we're never gonna reinforce that behavior again, that behavior is gonna extinguish pretty quickly. If I don't continue to reinforce, it's gonna stop. Okay, but generally when we're trying to train or get organisms to go through and acquire behavior, we generally want that behavior to persist in the absence of reinforcement. And so this is where we get into intermittent reinforcement schedules. Intermittent reinforcement can be very, very powerful in maintaining and making sure that whatever that target behavior is maintained sometimes over very long periods in the absence of reinforcement. And so if we're talking about an intermittent reinforcement schedule, what we're talking about is just some sort of reinforcement that doesn't happen every time, but it happens according to some sort of schedule, okay? So we had talked about, at the end of class, a fixed ratio schedule. Fixed means it's the reinforcement happens the same way every single time. Ratio means that the reinforcement is based on a specific number of responses. So again, if we're thinking about a rat in a Skinner box, right, and the behavior that we're wanting to reinforce is pressing a lever. Okay, a fixed ratio schedule. If we've got that rat on a fixed ratio schedule, let's say that rat after every 5 lever presses is going to get a food pellet. Okay, so 1, 2, 3, 4, 5 food pellet. 1, 2, 3, 4, 5 food pellet. 1, 2, 3, 4, 5 food pellet. So it's not getting reinforced every time. So it's not a continuous reinforcement schedule. It's intermittent. But what we have is a fixed schedule where it's the same after every 5, and the reinforcement is based on a specific number of responses, okay? So you think about this in real life where this is kind of used, think about like some sort of a rewards program, okay? If it's normal, not in the middle of a pandemic and we were at the university, you go to a university coffee shop, right? And you get a punch card. I get a free coffee after every 10 coffees I buy. This would be an example of a fixed ratio schedule. It's the same every single time I buy. If the target behavior here is buying coffee, right, and the company wants to increase or maintain the likelihood of buying coffee with them, I give you a punch card. After every 10 coffees that you buy, buying coffee being the target behavior, you get 1 for free, right? And so then I go through, I get my free coffee, that's reinforcing. And then I go through, buy another 10, get another free one, so on and so forth. So this is how we can understand a fixed ratio schedule. A variable ratio schedule, by contrast, the reinforcement is unpredictable. I don't know when the reinforcer is going to come. It's variable. It changes based on sort of in between each time I'm reinforced. Still a ratio schedule. So I'm being reinforced based on the number of responses or the number of target behaviors. I just never know exactly when that reinforcer is going to come. So again, if we go back to the rat in a cage with a Skinner box, if we've got that rat on a variable reinforcement schedule or a variable ratio reinforcement schedule for pressing that lever, we're still going to reward that rat after a certain number of lever presses. We just don't know how long it's going to take, right? So what we would do, because it's going to be at random. So maybe the first time rat goes 1, 2, 3, 4, 5, gets a reinforcer. And then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, reinforced. Then it goes again, 1, 2, reinforced. And then maybe the next time it goes 1, 2, 3, 4, 5, 6, 7, 8, 20 times reinforced. So it's still based, the reinforcement is based on the number of responses or the number of target behaviors. It's just the number of responses required to get a reward are completely at random. So it changes around, okay? So think about slot machines in a casino. Gambling is probably the best example of a variable ratio schedule. So I sit down at a slot machine and I put in money and I pull and I pull and I pull and I pull, and maybe I pull 15 times and then I win. And so I'm like, okay, I was reinforced. That's going to maintain that behavior. So I continue to pull, continue to pull, continue to pull. Let's say I go 20, let's say 40 times the next time before I win. Like, okay, I was about to give up, but now I go through 1, 2, 3, 4, 5, get maybe win again. So it's going to be a variable ratio schedule. I never know when I'm going to be reinforced, but I know that the number of, or the reinforcement is still based on the number of lever pulls that I've got. Okay, so this is a fixed ratio and a variable ratio. This is going to be different than a fixed interval schedule, ratio schedule is going to be different than interval schedules. So with a fixed interval schedule, what I'm going to do, instead of with a ratio schedule where I'm basing my reward or my reinforcer on a number of responses, on an interval schedule, I'm going to provide a reinforcer after some amount of time is elapsed. Okay, so this is a little bit different. If, let's say, fixed means it's the same. Okay, so let's say that I've got a rat in a cage, and again, that rat's in a Skinner box. This time, what I've got, if I've got the rat on a fixed interval schedule, I'm going to go through and let's say I'm going to reinforce that rat every 30 seconds as long as it's there pushing the lever. Okay, so in this situation, the rat might go through and press the lever 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, might press it 50 times. But after that 30 seconds has come up, it's going to get a pellet. And then maybe it presses it again 50 times, 60 times. But after 30 seconds, it's going to get another pellet. Then maybe that rat's kind of worn out. Maybe a rat's getting kind of lazy, presses the lever 4 or 5 times. 30 seconds, it's going to get a pellet. So as long as the rat is at that bar pressing the lever, every 30 seconds, it's going to go through and it's going to get reinforced. So the number of times that the rat actually presses the bar is inconsequential. It doesn't matter. What we've got this rat on is a fixed interval schedule, and so the reinforcement is based on a specified amount of time, more so than and not at all on the number of presses here. Okay, so if we think about if you this isn't something people do too often anymore, but mail delivery, right? There was a time and a place where your mailman would come sort of at a given point in time, right? What we would see maybe is, people going through, if the target behavior is checking your mailbox to see if the mailman has come by. So you go through and you check and you check and you don't check, or you check. Maybe you check, you're excited for a package, so you check the mail 50 times, or maybe you're not excited and you check 3 times. But at a certain time every day, that mailman is going to come in, deliver packages, mail, and that's going to be the reinforcer. So in that situation with mail, we'd think about the checking behavior as the target, the mailman delivering mail as the reinforcer, but it just happens sort of at the same time. Okay. This is going to be different than a variable interval schedule. Again, still an interval schedule. So we're going to reinforce based on some unknown amount or some amount of time. It's just we don't know how much time is going to pass before we go through and reinforce. So here, again, rat in a Skinner box. What we're going to do, because this is a variable interval, maybe the first time we reinforce the rat after 30 seconds, and then reinforce the rat after 20 seconds, and then reinforce the rat after 3 minutes, and then maybe after 10 seconds, and then maybe after a minute and a half. And so it doesn't actually matter how many times the rat presses that lever in between the reinforcers. As long as it's there at the bar doing what it's supposed to be doing, it's going to get reinforced, right? It's just that we've got a variable interval schedule here, and so the amount of time between each reinforcer is random. It's unknown versus a fixed interval where it's the same amount of time each time, okay? For variable interval schedule, an example will be, let's say, if I'm looking on social media. Social media is kind of a variable interval schedule. I post something, I guess, not on social media, but I guess this is the way it works, right? So I post something and then want to see if people like it or respond to it or something like that. And so I'm going to go through and check, and sometimes it's going to take people, someone might respond instantaneously. Sometimes it might take a couple minutes, maybe a couple hours. I don't know how popular you are on social media. But again, if the reinforcer or the target behavior is checking your social media, and the reinforcer is someone replying, this would be an example of a variable interval schedule. Okay. So again, when you're trying to keep this straight in your mind, remember that ratio schedules are determined by the number of responses. Interval schedules are determined by elapsed time. Fixed just means that it's the same every time. Variable means that it's just that it's random. So again, you can put yourself in a 2x2 box here and start very quickly to determine what type of reinforcement schedule that we're talking about. Okay. Now, what's really cool, what we see is how we go through and set up these reinforcement schedules really starts to impact the types of behavior that we see. Okay, what we see with a ratio schedule. Again, a ratio schedule is reinforcement based on the number of responses. Okay, and what we see with ratio schedules is we typically see higher levels of responding or higher levels of behavior if we've got some organism on a ratio schedule. Okay, and if we look here, this is your variable ratio schedule and your fixed ratio schedule. Okay, so here I'm reinforcing on number of bar presses in the variable ratio. The number of bar presses I need to get before I reinforce is unknown. With the fixed, it's a set number. And what we see is very high levels of responding with this type of reinforcement schedule. Because if you think about it, if I'm the rat in a cage, how do I maximize my reward? With a ratio schedule, I maximize my reward by pressing that bar as fast as I can, because the faster I press it, the more responses I've got, the more reinforcements that's going to come my way. Okay, so we typically see with ratio schedules a very high rate of responding relative to interval schedules. With interval schedules here, what we're getting is something a little bit different. We see a slower rate of response with interval, right? So here we've got a variable interval. I'm going to go through, and as long as I'm engaging in the target behavior between some unknown period of time, I'm going to get reinforced. So what we see is a slower set of behavior, or slower rate of behavior right here with the variable interval. I'm just going to sit by, if I'm a rat in a cage, I'm just going to sit by this lever and just kind of press it, right? And eventually, so as long as I'm just kind of there doing it, I'll get reinforced eventually. Between some undetermined amount of time, I'll keep getting reinforcers. Sometimes it's 30 seconds, sometimes it's 40, sometimes it's a minute and a half, sometimes it's 10. As long as I'm there kind of doing it, so you get these kind of this slow, steady level of responding with variable interval. Something interesting happens with fixed interval, and we'll talk about this in the next slide, or in the next section, is with fixed interval, we get kind of this waved, scalloped pattern, which kind of makes sense if you think about it, right? So I'm a rat in a cage, right? And let's say that I know that so that I'm getting reinforced for bar pressing every 30 seconds. So I'm going to go through and I'm kind of being lazy, pressing the bar. But as I get closer and closer and closer to that 30-second mark, the intensity of the lever pressing increases until I hit 30 seconds. And then I'm sort of going to kind of wean down, right? So then kind of lazy, pick back up, get higher and higher, or get more and more intense as I hit that 30-second point, and then kind of level off. And then as I get closer and closer to the next one, up, level off, up, level off. And so what's interesting in this fixed interval schedule is we see this reliable kind of scallop pattern where the intensity of behavior increases as we get closer and closer in time to when we go through and reinforce. And so with a variable schedule, we generally see much more persistent behavior that's resistant to extinction. So let's say, for example, that I go through and someone has been dumb and they set up a slot machine to be on a variable ratio schedule, okay? So I pull 10 times and I win, and I pull 10 times and I win, and I pull 10 times and I win, okay? But then let's say things shut off and this machine will never pay out again, right? So I go pull 10 times and I don't get rewarded. And I'm like, huh. And I pull another 10 times and I don't get rewarded. I might pull another 10 times, but if I don't get rewarded then I'm done, right? And what we've said is that behavior is extinguished, okay? Because again, it's on a fixed ratio schedule where if that reinforcer doesn't come when I expect it, and it's never going to come again, pretty soon that behavior is going to terminate in the absence of continued reward. But with a variable schedule, remember the variable ratio, that's what slot machines are actually set up on, right? And this is provides very, very, very durable behavior. I'll go through and I pull, win, and then I'm going to sit there and I'm going to pull. I might pull that lever 50, 100 times before I get reinforced again, right? That was a lot of behavior that occurred in the absence of reinforcement. But then I get reinforced, and then it just maintains that behavior. I'm going to pull. I'm going to play in the absence of winning, sometimes for a very long time, just because of the really, really durable behavior that variable schedules will cause. Okay, so what's interesting here is that we see different types of behavior and different maintenances of behavior, different intensities of behavior, depending on what type of reinforcement schedule that we choose. Okay. Fixed interval, we talked about the fixed interval, kind of the scout pattern here. What we see, again, is an increase in behavior as we get closer and closer to that period of reinforcement. Again, if I'm being reinforced every 30 seconds or 5 minutes or something like that, behavior is kind of lazy until we get closer and closer to the reinforcement time. Then it increases, and then we kind of tapers off and increases, tapers off, increases, and you get kind of this scalloped wavy pattern here. Okay, our fixed ratio schedule, again, what we see here is we see some level of behavior bursts, but less pronounced in response to the fixed interval. Remember, the interval is based on, interval schedules are reinforced based on a period of time. So we see this really pronounced scalloping pattern. Fixed ratio, we get a little bit, right? If I know that I'm going to be reinforced, if I'm a rat in a cage and I know that I'm going to be reinforced after every 10th press, let's say, I might see as I get closer and closer to 10, the rate of responding pick up a little bit, but for the most part, it's going to be pretty intense high levels across the whole range here. So some different types of patterns here with the different reinforcement schedules. All right, so up to this point, we've been talking about reinforcement schedules, okay? And reinforcement schedules are really, really effective in providing information on what to do. But we can also go through and sometimes we've got a target behavior that we don't want to increase. Remember that a reinforcement schedule, by definition, is any type of thing that we're doing to increase the likelihood of a behavior. So remember, I had said before, when you're trying to tease this apart, what you always want to do is you want to say, okay, what's the target behavior? Do I want to increase that target behavior? If I want to increase that target behavior, that's going to be a reinforcement schedule. But if I want to decrease that target behavior, then we're talking about a punisher. Okay, a punisher is any event or stimuli that's going to decrease a target behavior. Okay, so when you're trying to tease this apart, number one thing, identify what the target behavior is and make sure that the target behavior is something that's occurring, something that's not occurring, right? Not screwing around is not a target behavior because not screwing around looks like a lot of things. What I would want to do in that situation is set my target behavior to be on task study behavior or something like that. So one, identify the target behavior, make sure the target behavior is something active, it's something the organism is doing, and then say, do I want this thing to increase or do I want this thing to decrease? If we're trying to increase it, we're working with a reinforcement schedule. If we're trying to decrease it, we're working with a punisher. Okay. And so when we get into, just as we had positive and negative reinforcers, we can have positive and negative punishers. Positive punishment is going to be a schedule or a system where we decrease behavior by applying generally some sort of aversive stimulus. Now, remember that positive just means giving, negative means taking something away. That's all positive and negative means. Now, positive punishment generally involves applying something, or sort of something that's kind of aversive, but it doesn't necessarily have to be. Positive punishment is just, I'm giving something to decrease a target behavior, okay? So for examples here, traffic ticket, okay? If the traffic ticket, if the target behavior is speeding, speeding is something that we want to decrease. If I have officers out on the road, I'm speeding, I get a ticket, that's going to reduce, the idea is that that's going to reduce the continued occurrence or the likely continued occurrence of that target behavior that we want to shut down. Okay, same thing, corporal punishment, spanking, right? Let's say you're hitting your sister or your brother, whoever you're hitting. We don't want you to hit anybody. Hitting in general, doesn't matter who the target is. We want that behavior to decrease. So the target behavior is aggression. We want aggression to decrease. Corporal punishment is based on, I'm going to give you something, a spanking, physical punishment that then, or a physical contact that's going to reduce the likelihood of continued aggressive behavior for you. Okay, so again, this would be positive punishment. We also have negative punishment. Okay, negative punishment, here we're going to decrease a target behavior by removing something. Okay, usually a desired stimulus, but again, remember that positive just means give, negative means take away, and in any case where we've got a target behavior, we're trying to decrease it, that's going to be a punisher. Okay, so if I am talking about grounding, okay, again, let's say, again, target behavior is aggression, right? And so instead of giving you something to reduce that aggressive behavior, what I do, you hit somebody and I take away privileges or freedom or something along those lines. That's going to be an example of a negative punisher. Okay. Let's say you break curfew, so I take away your cell phone or something like that. So again, it's going to be, I'm removing some type of thing or put someone in timeout, right? You get put in timeout. That's a negative punisher, right? What I'm doing is I'm removing attention from you in order to decrease a behavior. This is going to be an example of negative punishment. Okay. All right. So when we're thinking about sort of how to structure and how to shape behavior, one of the big questions is like, oh, well, what's better, punishers or reinforcers, right? And in terms of like kid stuff, this starts to get really intense. People have strong feelings about this, like, should I spank my kids or should I ground my kids? Like, sort of, what should we go through and do? Okay. A lot of this is cultural issue, but what we do know from science is that reinforcers are a very good way to provide information on what to do, right? Reinforcers give me, I'm engaged in some behavior, I get reinforced for it, it's likely to increase the likelihood of that behavior. Punishers provide information on what not to do. So when we're thinking about how to shape behavior, it starts to become important to sort of start to think about, okay, like, what are we trying to accomplish in this situation? Okay, now if you, let's say you want to teach your dog to fetch, right? And you decide to beat your dog for not fetching, the dog's going to be super confused by that. That's not going to be an effective way to go through and do it, right? Because it's getting punished for sitting there, but it's not sure what it's supposed to be getting or what it's getting punished for. And so instead it sort of maybe just runs off and then you hit it and it sort of does something else, you hit it. This is a violent example and upsetting. I don't want anybody hit dogs. But again, we can think about how we apply these different systems in ways that are not effective, right? So if I want my dog to fetch, instead of punishing it for not fetching, probably the better thing to do is going to go through and reinforce it for successive approximations for fetching. And if it does fetch, praise it. Lots of reinforcers there. As it's doing things that are kind of there, you sort of give a little bit of reinforcers, working on some of that shaping behavior, okay? So again, just remember that reinforcers provide information on what to do, punishers generally providing information on what not to do. And again, going back to this can get really tricky, and it's easy to do gymnastics in your head and overthink this and turn things around. Always, always, always what you want to do is first decide what the target behavior is. And then once you've got that, then determining whether or not we're talking about a reinforcement schedule, a punishment schedule, and whether it's positive or negative will start to fall into place pretty quickly. Okay. So one thing with conditioning, important to remember that organisms' capacity for conditioning is constrained to some extent by genetics biology. I can't teach all animals to do all types of things. I can't condition or assign associative learning equally well to all certain types of things. There are some things that organisms, including ourselves, are very easily sort of paired up. There are things that we can learn very quickly and are very easily conditioned, and these are called prepared associations. So things like taste and physical illness. If there was ever a situation in your lifetime where you ate something or perhaps drank something in excess and it made you quite physically ill, it's probably not unlikely that you develop a pretty strong aversion to the taste of whatever that was after just 1 or 2 episodes, right? And this makes a lot of sense. If I'm out there in the as a developing human in prehistory and I eat something and it makes me sick, that probably means it's poison. I shouldn't be eating it. If I go back and I eat it again and again and again, it's going to kill me, and that's not an adaptive thing, right? So we think about this association between taste and physical illness as a thing that's very, very easy to condition. Same thing, auditory visual cues and shocks. Right? If I brought you into the lab and I give you some I flash dots on a screen in front of you of different colors, and every time a green dot comes up, you get a really bad shock. Okay. It wouldn't take too long for you to start to respond physiologically to green stimuli with sort of increased physiological activation. Maybe your sort of heart rate increase, starts sweating and breathing and things like that. We're really good at associating physical auditory cues with pain or aversive stimuli. We do a good job with that, right? And then we see phobic fears of things like snakes and closed places, things that we see quite commonly across cultures. These are all things that we would think about as prepared. We're kind of biologically wired to make these connections, right? But we also have things called contra-prepared associations. These are things that are very difficult or impossible associations to acquire, okay? So let's say taste and shock, like physical pain or something like that. Let's say I brought you into the lab and had you go through and I gave you a bowl of jelly beans. And every time, let's say they're Jelly Bellies, and every time you got a popcorn jelly bean, you got an electric shock. Probably, even if I had you eating jelly beans and shocked you quite a bit, probably you would not develop an intense physiological response to the taste of popcorn. It's just our bodies don't make that connection. Same thing with visual cues and physical illness, that sort of nausea that we get with taste. It would probably be hard for me to condition you to have a nausea response to the color red or something along those lines. It doesn't just fit, right? Same thing when we're looking at fears. Phobic fears of things that are far more likely to kill us than snakes and enclosed places, right? Like firearms, heart disease, other stuff that, kills people on the reg and is really dangerous. We don't see natural prepared phobic responses to these. I'm not going to say never, but it's not like fear of snakes and spiders and things along those lines. And from an evolutionary psychology standpoint, we would say that we have certain things that we're wired to be afraid of that signal danger in a naturalistic sense, whereas some things in our modern world that are far more likely to harm us or hurt us, we don't see people having widespread fears of those types of things. And again, just getting back to this prepared contra-paired association thing. Okay. All right. So make sure that you go through, take a look at the lecture summary slides. Make sure that you go through, run a comprehension check slide, run through examples of these, either things that you've found, things that I've given you, examples you've come up on your own in order to really sort of get this stuff down. So going to switch over and work through observational learning. This stuff is pretty quick. It won't take us too long to work through. Through this whole point, up to this point, with the classical conditioning, with the operant conditioning, we're just working on stimulus response types of things, right? This is the bread and butter of classic behavioralism, right? But if you remember that the radical behaviorists, sort of those original behaviorists, strict behaviorists, argued that all of our behavior could be explained as some stimulus response reaction, right? This idea of thoughts, emotions, sort of free will, things like that. I can't observe your free will. I can't observe your wants and your wishes, your preferences. All I can observe are stimuli in the environment and your behavior. And so if I'm a radical behaviorist, I'm not even recognizing thoughts, feelings, free will as concepts that are worth studying because I can't directly observe it. If I'm a classic behaviorist, I say that all behavior, everything that we do, can be explained as a product of classical and operant conditioning. Okay, and again, this is sort of our boy B.F. Skinner here, a guy he was big on operant conditioning. He looks like, he looks like old Wolverine. But when people asked Skinner about this in 1980, right? They said, Skinner's quoted as saying, "I'm sometimes asked, do you think of yourself as the organism you study? The answer is yes. So far as I know, my behavior in any given moment has been nothing more than the product of my genetic endowment, my personal history, and the current setting," right? So Skinner was very serious about this. He's like, yes, my own stuff, and this is a brilliant man, right? He's like, but my behavior at any point in time, as far as I know, is based completely on sort of my genes, my learning history, and what's going on right now, right? Which is pretty intense, right? He's even in his own life, he's like, I don't do things because I want to or because I have free will. It's because I've been conditioned to do them, right? But as we start to go through, and so you understand this kind of the position that those initial radical behaviorists were basing. But when we start to go through and take a look at actual behavior, there's a lot of things that happen that are really hard to explain without pulling in some sort of cognitive or internal mental process. Okay. For example, we talked about this scalloped pattern, this variable responding during fixed interval reinforcement. So again, I've got a rat in a cage, and I'm going to, looks like here, going to reinforce. Let's say we're giving this rat shots of cocaine or something like that, some sort of chemical stimulus every 5 minutes, right? And we see things kind of taper off, but then it's getting more and more intense until we hit that 5-minute point. It gets the reinforcer, and then things kind of taper off. Okay, whoops, where's my cursor? Kind of taper off, get more and more intense as we get closer to that 5-minute point, and then we taper off until we get closer and closer and closer. Increase, reinforcer, taper off, increase, taper off. What it looks like, based on this, is that rat is anticipating being reinforced, right? What we're saying is this rat has started to understand that I'm getting reinforced about the same time, about this time, and as I get closer and closer to that time where I've gotten reinforced, I increase my behavior in anticipation of that reinforcement, right? But if I'm a strict behaviorist, if I'm a radical behaviorist, this idea of thoughts and awareness or anticipation doesn't make sense because I can't see anticipation. I can't, that's not something that fits into my sort of lexicon here, right? Rats anticipating or knowing or recognizing, those are all cognitive words that I don't include in my model, right? But it's hard to make an argument that something's weird's not going on because we see this very reliable scalloped pattern, okay? We also see evidence of latent learning in mice running maze trials, okay? So what we've got here is, let's say we've got a mouse, right? And we put this mouse in a maze. And we just drop this mouse in a maze, and there's no cheese, there's no reinforcement. We just drop this mouse in a maze and let this mouse spend say, an hour in the maze, right? And let's say we do this for a period of 3 days in a row. Drop the mouse in a maze. Let's just let the mouse wander around. Mouse isn't trying to get from one end to the other. Mouse is just kind of tooling around, doing whatever, okay? Now, from a strict behavior standpoint, we would say that this mouse isn't learning anything, right? Because it's had no reinforcer. There's no reason for it to learn or acquire any behavior, any learned behavior, because there's no reinforcement. There's nothing sort of external going on, right? But when we take those mice that we've let just kind of wander around for 5 days in a row for about an hour in that maze, and let's say that day 6, what we do is we drop that mouse at the beginning of the maze and we put some cheese at the end of the maze, that mouse will run that maze very, very quickly, much more quickly than a mouse that we drop in who's never seen the maze before. Okay, and so again, what we would say, the explanation seems pretty easy, right? Well, the mouse learned the maze because it was in there, and it kind of, for several days, and it kind of learned what the maze was. But if I'm a radical behaviorist, that doesn't make sense, because learning doesn't acquire outside of having some sort of reinforcement or consequence. And so this idea that this mouse had developed a mental map, again, is a cognitive thing, and so that's against the rules based on my model. Okay, but it's happening, and it's hard to account for, right? Another example has come up in class: aversion therapies for alcohol and substance, right? What we see here is, again, like an abuse. Let's say someone has struggles with alcohol use, and what we do is we have a medication, and I give you that medication, and if you drink alcohol while you're on this medication, it's going to make you violently, violently, violently ill. And if you're violently, violently, violently ill, after having drank alcohol, the rules of behaviorism say that you should develop an aversion to that alcohol, and just seeing it, smelling it should make you quite ill, right? But what we see is that aversion therapies work okay as long as people are taking the medication, because it's a literal barrier to them going through and benefiting from the effects of alcohol. But as soon as we take people off of that, they'll go back to drinking very quickly, right? Which shouldn't happen. After I become incredibly ill from drinking, I should never want to see it again, right? And maybe you've done that. In fact, I'm never drinking again. I'm done. So never having another drink in my life. What happens the next weekend? You're back at it, right? Which shouldn't happen based on if everything was just a basis of classic and operant conditioning. So what we do know is that cognition does matter. To some extent, there are cognitive processes that sort of in play and starting to become important for considering these. So the radical behaviorist position is weak from a scientific evidence point. Okay. And so this is where we get into some observational learning, right? And again, this seems pretty straightforward and common sense if you're a lay person. But again, for scientists, it starts to become difficult to sort of understand and comprehend, right? If we're talking about observational learning, we're talking about behavior acquired through observation of some other target, and modeling being a process of observing and imitating some behavior. Okay, and one of the classic experiments in observational learning is what is now known as the Bobo-Doll experiment. In the 60s, an investigator named Albert Bandura, was interested in sort of learning or sort of better understanding how we acquire certain types of aggressive behaviors. And so what Bandura did is had kids come into a room and put kids in with a Confederate. Now, in psychological research, if I've gotten a Confederate in a study, it just means someone who's in on the study. Someone who, as a participant, I don't know that they're in on it, but they're in on it. They're part of the research team, and they're kind of playing a part. Okay, and so what Bandura did was have kids come in and put them in a room with a Confederate. Okay, 2 different conditions. In the first condition, kid came in, and the Confederate's playing quietly with toys on the opposite side of the room, and in that room there's a Bobo doll. This is a Bobo doll. This is one of these inflatable dolls that's weighted at the bottom. You kick it, and it sort of knocks over, pops back up. This was a big thing in the 60s. You got a clown thing. It's kind of horrifying, but you go through, and it's just something you can kick and sort of aggress on, but it doesn't really do anything, right? So in condition 1, kids came in, or a kid comes in, there's a Confederate, an adult in the room, but the adult's on the opposite side of the room, just kind of playing with some toys, just being quiet, no interaction with that Bobo doll. Okay, kids in the other condition. though. Kid comes in, there's a Confederate in the opposite, the right side of the room, ignoring the toys, and he's just going to town on the boba doll, kicking the boba doll, punching the boba doll, hitting the boba doll, knocking the boba doll around, so on and so forth. Okay, so we've got these kids, two different conditions. They're brought in individually. In the one condition, there's a Confederate in the room who's playing quietly with toys. In the other condition, Confederate in the room going to town on this boba doll. Okay. So what they did is after the kid was in the room for a while, they're doing something, talking to the kid, right? And then what they do is they take kids out of the room and say, okay, what I'm going to do is I'm going to go through and take you, come with me. I'm going to put you in this room with these toys. Okay. And in this room, there are sort of really desirable toys. Like, I don't know what the equivalent of like Xbox and PlayStation was in 61, but something along, like, they're really cool toys. They're fun stuff, right? And so they let the kids play with these awesome 1960 toys for about 2 minutes, and then the investigator comes in and says, "Oh, whoops, I'm sorry, we made a mistake. These are the best. These toys are the very best toys. These are reserved for other special children. What we need to do is we need to put you in the right room. We made a mistake, right?" And so what they did is they take the kid to a third room with a bunch of crap toys and a bobo doll. Okay. And so what they did was go through, and here is I'll send you the link. I don't know. Oh, you can't hear that anyway. Okay. We'll go through, or maybe you can. I don't know. We'll go through. I'll give you the link. You can watch sort of what's going on with this boba doll experiment, right? But what they did is, so they prime these kids with either the aggressive Confederate or the non-aggressive Confederate. Then they went through, dropped them in a room, let them play with these awesome toys for about 2 minutes. Then they said, "Oh no, whoops, those are for toys for kids who are better than you. Here, let me take you in. This is the room you need to be. Here's with a bunch of crap toys and a boba doll." And what they were interested in is whether or not they saw differences in the behavior of the kids who had been exposed to the aggressive model, or kids who were relative to kids who were with a model who didn't interact with the boba doll. And what they found, not surprisingly, is that exposure to aggressive models resulted in higher levels of aggressive behavior in these kids. Okay, and those who had been exposed to aggressive models generated or engaged in more creative forms of violence. So across both conditions, right, kids in general would go to the boba doll because it was the most interesting thing there, and they would sort of kick and punch because that's what you do with a boba doll. Okay, but the kids who had been exposed to an aggressive model, much higher levels of aggression and much more creative forms of violence. So you watch that video, like there's a kid, I don't know, they grow up to be a serial killer or something like that. They're really getting creative in how they're aggressing on that bobo doll. Okay, and so we're seeing clear differences based on just this mere exposure to this model. And the model didn't interact with the kid. The model wasn't like, "Hey, come over here and help me smack around this bobo doll." It was just in there and just sort of having that go on in the background, right? Now, if and Bandura was a behaviorist, right? Bandura sort of trained in this strict behaviorist condition, and so trying to understand what's going on is kind of a hard thing, right? Because the kid themselves had never been reinforced for aggressing on the doll. They had never sort of had any sort of, in this study, any type of external reinforcement for anything, right? And so what Bandura proposed is that this observational learning phenomenon is occurring through vicarious reinforcement and vicarious punishment, okay? And this idea is, again, because I'm a behaviorist, I'm a Bandura, and I sort of work on things of punishments and rewards. That's how I understand the world. And so in trying to understand how people acquire behavior without direct reinforcement or direct punishment, this observational learning, Bandura described as a process of vicarious reinforcement and vicarious punishment, which basically means we're anticipating consequences based on observing other people. So in the boba doll experiment, right, we would say that the kids who watched the adult Confederate kick the boba doll, throw the boba doll around, they seem to be having fun. What Bandura would say in his model is that those children had received vicarious reinforcement for aggressing on this Bobadal in strange and interesting ways, okay? Because they'd watch someone else do it. That other person seemed to be having fun, which then within Bandura's model would say that they've been vicariously reinforced for that behavior, okay? Versus those kids who were exposed to the Confederate who was not aggressing on the Bobadal. There was no reinforcement for engaging in aggressive behavior on the Bobadal, and so therefore it's not that the behavior didn't happen, it just wasn't intense or creative as the other group because they hadn't been reinforced, okay? Same type of thing if you're any CJ folks, right? Sort of our system of law enforcement and punishment is to some extent, death penalty stuff is based on this idea of vicarious punishment, right? Like this idea that the death penalty is a deterrent, right? Because what I don't want to do is have a system where I have to kill somebody to get punished for killing somebody, right? Because then I've already killed somebody and that's a problem. That's not an efficient system, right? The idea being that what happens is why people don't kill people is that we know or we receive vicarious punishment because if someone does kill somebody or assault somebody, then they go to jail or prison, sort of so on and so forth. And that this then creates observational learning through vicarious punishment. I'm vicariously punished through this because I see someone else being punished, which then vicariously punishes me, which reduces the likelihood that I'm going to kill somebody, okay? Now, if you're in CJ, you understand that that's not exactly how it works. Death penalty doesn't seem to work very well as a deterrent on that level. We know that just because there's lots of research out there. But it's the idea that if I see someone else being punished for something, right, let's say let's lower the stakes. We're not talking about murder. But let's say my brother talks back to my mom and he gets grounded, right? I didn't have anything to do with that, but I watched it, and the idea is that I would receive vicarious punishment by watching my brother be punished for that. That vicariously punishes me, therefore I'm less likely to sass back or something along those lines, right? Same thing, we talked about gambling, right? Maybe I've never gambled before, right? But if I'm around in a casino and I'm seeing lots of people winning, I'm seeing bells and things like that go off, the idea would be that I'm being vicariously reinforced for gambling, even though I'm not gambling, because I'm watching other people, what I perceive to be winning, and so therefore it's going to increase my likelihood of modeling that behavior and going through and gambling, okay? So some interesting stuff here with observational learning, okay? Now, if we think about observational learning, really, really important to the acquisition of adaptive behavior that allows us to navigate society, okay? Remember last unit we talked about norms and cultural norms and things along these lines. Observational learning is how we pick this stuff up, right? We see people make mistakes or violate norms and get sort of directly or indirectly punished for it, which prevents us from making the same mistakes. We see people be rewarded for work ethic or values or sort of things along these lines, or do hard work, and so then we're more likely to do that. Social movements, which are huge, right? In terms of stuff going on right now, like I don't have to experience something or some sort of systematic impact on my in-group or to me personally, but what I see is other people sort of engaging in behavior, social movement stuff, and sort of starting to go in, increasing the likelihood of me engaging in similar behaviors based on watching stuff in other people, right? So again and again, adherence of social norms, expectations, all of this is observational learning. We don't get a manual on how to be a reasonable person when we come out of the womb. We pick this up by some of it's stimulus response, classical conditioning, operant conditioning, but a lot of it's going to be observational learning, okay? Cons, a lot of observational learning being a main pathway for a lot of not so great behaviors, in addition to aggressive behavior. What we see is children of, for example, children of physically abusive parents are more likely to be aggressive. Perpetrators of domestic violence more likely to have fathers who engaged in domestic violence. Some evidence that exposure to media violence is associated with increased aggression, although there's several asterisks there. The direct impact of that is probably pretty limited and maybe kind of state specific after we control for other stuff. It definitely does not mean that people who play violent video games or listen to metal music are going to go out and murder people, but it looks like there is some transfer of increased proclivity for certain types of aggressive behavior based on sort of watching this, viewing this, and sort of having this modeled. Okay, so we see both imitation, modeling, and desensitization contribute to aggressive behavior. If I grew up in a household where disagreements were solved by physical fights, right? The likelihood of me engaging in physical fights increases quite a bit, right? If I've grew up in a home where no one ever got in a fight with anybody, at least physically, no one ever beat anybody up, no one ever punched anybody else with a fist, attacking somebody if I have a disagreement with them isn't even in my repertoire of possible options, right? It is not even something that occurs to me. But if I've grown up in a house where that's how we deal with stuff, is sometimes you got to throw down, then that's sort of one of several options I might take. It might be the first option I take moving forward. And it's not shocking or horrifying, or I'm not even worried about it, right? It's just like, oh, this is how things happen, right? But it's easy to see working with kids who have been in difficult homes that have been plagued by violence and things like that, right? Like you become desensitized. It's not a big deal. Like sometimes people hit people. Like I don't see what the big deal is. Whereas if you're sort of a member of sort of following by societal rules where we don't use aggression to directly resolve conflict, that's going to be more shocking and going to be a barrier. So again, we see both pros and cons to observational learning, but we pick this up a whole lot. Okay. So again, told you that one was going to be short. Make sure you go through lecture summary, comprehension check slide here. So just making sure that you're working through these, and then I'll send you the link to that Boba doll experiment because it's old-timey video that's pretty funny and stuff. Okay. All right, folks. Thanks for hanging in there. Apologies that we're having connection issues yesterday, but we'll get this put up. Make sure you go through, watch it, and let me know if you have any questions. All right. Thanks a lot.